All right, so we're going to cover the last topic of the course. Yeah, question. What's that? The sorting lab is due this Friday. Yeah. The sorting lab is due this Friday. The application lab is due next week. Wait a minute. It's due the Friday in which December 7th occurs. I don't know which Friday that is. Oh, December 7th is, I'm sorry. I want the application to be done the Friday before December 7th. So the Friday of, oh no, here it is. It's this lab day, I think. Wait a minute, I'm confused here. So December 7th, I think I had the dates messed up here. Well, December 7th is a Monday. And December 9 is the final exam. So I'd like the lab done, the final lab done on the 7th, on that lab day, as opposed to, say, the 11th. But if you want more time on it, just talk to me about it. All right, I think that's enough time. All right, so this is the final topic, and it's on application development. So we're going to write a program which is larger than the programs we've seen so far. So we want, rather than doing a piece of a problem, a piece of a program, we want to get something that's sort of usable for some purpose. And for this will be to play Tic Tac Toe. So your job is to write a program in which the user plays Tic Tac Toe with the computer. And now, in this course, all of our programs are console-based, so it has that text interface. So you run the program at the terminal window, type in text and numbers, right? Characters, alphanumeric characters and whatnot, in from the keyboard, and they get your response in that terminal window. It's not the normal way that programs are used by end users. Normally you have a graphical user interface, but we did not cover that topic. A graphical user interface, that means that the program runs inside one of these windows, like this browser window. Okay? Or even the terminal window itself, it's run inside of a window. In older systems, and very old systems, you didn't have windows like this. All you had was this terminal window. That was it. The whole screen was the inside of this terminal window. But since those days, programs have moved into these sort of what's called a graphical user interface. But that's not a topic, so we're going to work inside this console interface. And so you need to play tic-tac-toe. You need to write the code so that the user plays tic-tac-toe inside that console. So basically you print the grid with the X's and O's, let the user make a choice about where they're going to place their X or their O, and then the computer decides where to go, and then you print the next version of the tic-tac-toe board. You either declare a winner or declare a tie or ask the user for his or her next move. And there's lots of code on the internet that does this, but you need to resist the temptation to look up the answer and just use that, because you're not going to learn anything that way. So this part of the course is about sort of transitioning into sort of software developer mode. This is what software developers do. They get these problems, these things like Tic Tac Toe games or whatnot, that they need to write, they need to develop. And so they need to carry out a sequence of activities that ends up with a finished program. It's like building a house. First you have some plans, you lay the foundation, you dig out the foundation, level the ground, pour the concrete. You do it step by step, and it's a lot of work. It takes a lot of time, and it's something that you need to practice. So this will be, for some of you perhaps, your first opportunity to practice doing software development. And if you look up the answer, you're going to be sort of cheating yourself a little bit, quite a bit. But to figure out a process, you need to work it out in your mind. What's the process you're going to use to build this thing? And so what I'll do is illustrate to you a procedure that you can follow to solve this problem. So we're going to solve a related problem, and then you'll watch me, listen to me solve a related problem, and you'll say, oh, that's how you do it, step by step. That's how you do the incremental development. Also, I'll show you basically how the console interface will work as well. So what I'm going to do is implement a game called Connect 4. So this is similar to Tic Tac Toe. The user has a move, the computer has a move. And then at any point in this process, there could be one of the players would then could win, or there could be a tie. So this is Connect 4. So that the computer went first. So the computer is playing red. And the idea is you want to get 4 of your color in a row. So they could be 4 horizontally grouped, or vertically grouped, or grouped on a diagonal. And you can see at the top of the screen here, there's a little triangle that shows where the user's move, where the user's icon is going to go. So I played there, the computer then plays here. But basically, we're playing against the computer. And go there. So I'll lose, right? If the computer plays here, I'm going to lose. So I'll just lose. There we go. So the computer gets 4 in a row along the diagonal, and that's the win. So you can see how this is similar to Tic Tac Toe. Maybe there's a Tic Tac Toe game, right? Tic Tac Toe. Online. Let's see that. I haven't checked this yet. Let's see. It's taking too long. There we go. So I played in the middle, the computer plays here. So this is what you need to implement. I play here, computer plays there. I play there, computer wins. But now when you implement this game, I mean, you can use sophisticated logic if you want, but for the purposes of this assignment, I recommend just choosing a random location. So when the user enters in a location, then the computer selects a random location. That's good enough for this assignment. If you want to do more than that, make it more challenging, you could do something like the computer could always choose the center cell if it's available. It could follow a rule like that, something like that. You see the similarity, right? User plays, the computer plays. I thought I was going to get an easy win there. Anyway, I don't want to keep playing. All right, how are we going to do that? How are we going to implement Connect 4? All right. I'm going to make a directory called, actually, it's just a single file. So we'll go ahead and make that. So I'll call it connect4.cpp. So what's the first thing? What do you think I'm going to do? What's the first thing I'm going to do? Huh? Remember, the key here is incremental development. I just want to make sure the build environment is set up. You know, I got my editors working. I got a hello program that's compiling and running. That's it. That's my first step. And then you're going to think past that. So include IOStream using namespace std. That should be a U. Integer main. I'm not going to check any arguments. That's my first step right there. Compile it, run it. Looks good. So incremental development. Don't get too, I mean, I've done this problem before, so, you know, I'm cheating a little bit. But this is how I would start this problem. Now what we need to do, let's break it down. We can't do everything all at once. We can't just code up the whole solution, right? I mean, that's way too complex. We have to break it up into steps, into pieces. So and you can break these problems up in different ways. And the way that I want to break this up right now, I'm just thinking, how can I break this up? I say, well, let's see. It's what's the interaction with the user? See, the computer will print something and then wait for the user to make a move. The user types in something on the keyboard, and then the computer will display the user's move, and then display the computer's move, and then wait for the user to make another move. All right, let's just craft that piece of the logic, okay? Just in a very rough way. So we have a loop. We need some kind of loop, and the user will be entering a data. So I'm going to just go ahead and make that an infinite loop. And the computer prints something. Maybe I print a grid, or I'll print a grid, and then I'll I'll ask the user to, so I'll print a grid, so it'll look like the Connect 4 grid. All right, so we're just going to say prints a grid. So that's the Connect 4 grid. All right. So we print the Connect 4 grid, whatever that's going to look like. And then we'll prompt the user to make a move. How does the user make a move? How are we going to input the move? Huh?
CE.
Cin, yeah, but what are we going to ask the user to type in? A string? Yeah. Huh? What's the input going to be that we're that the, huh? Column number. Yeah, it's a column number, right? Isn't that what it is? This is column 1. Yeah. So we're going to ask the user to type in a column number. For your move. And then so we'll read in a number there. So Cin column. We'll need to declare a column. Maybe I'll put it inside here. So we read it in. And then then we keep the loop. And then we print the new grid, because then we have to display, an X or an O, whatever we're going to use. And then we have to, we have to show that to the user. Let's see what this looks like. See, I enter column, I'm going to say column 1. Well, then I print the grid and I ask for another column 3. You see, that's what it's going to look like. Finally, it'll say, player wins, or computer wins, or tie game. Well, what happens, do we care about illegal moves? Like if I put in, say, 12, are we going to concern ourselves with illegal moves? Let's leave that part of the problem out, okay? Let's just leave it out, because it's like, also like things like, that's not a number, right? So look, it's an infinite loop. So are we going to check for invalid data input? Let's leave that out. Let's just attack the central part of the problem first. And these are little extra stuff that we can work on later. I want, for those who are wondering, why do we go into an infinite loop when we enter an invalid number? So when the system hits this statement right here, Cin column, then the program halts. And it waits for data to come from the keyboard, from the standard input stream, actually. And it waits for a chunk of data to come in. And then when it gets a chunk of data, it'll get a string, basically. The input stream, this input operator right here, will get some text. The user's going to type something and then hit enter. Then the operator gets that text that was entered in. And then this input operator will try to convert the text into an integer, which it stores into this column variable. And I typed in something that could not be converted to an integer. And that means this operation fails. So this input stream enters into what's called a fail state. So the input stream has a state. It's either everything's okay, or we're at the end of file, or there's an error, and we need to do something. So basically, when the user enters in an invalid value, the input stream enters into a fail state. And this operator won't block anymore. So when we run, the next time in the loop, when we get to this operator, the operator is going to say, hey, I can't do anything. The input stream is in a fail state. So it just returns without doing anything. Now we get the infinite loop. So now when the input stream goes into a fail state, we're not blocking on this statement anymore. So we're just getting a continuous loop. That's what's happening there. But like I said, let's not worry about that. Let's just focus on, let's just never enter in an invalid value. All right, so now the problem is, how are we going to, well, I would say, what do we got to do next? So right now we have what we have. You know, we're typing in these columns here. Let's, as a next step of development, let's print the grid and have the user's, what do you call it? The user's symbol occupy the right column. Just as the next step. That's how I would break it out. I mean, you could think of something else. If you have an idea, we could try something else to do next. So this is called incremental development. All right, so we're going to print this grid. And I know printing the grid is going to be complicated. So I'm just going to call a function print grid instead of putting it inside this loop. So that's a void function. So we want this main loop to be as simple as we can make it. There it is. Oops, I went into the infinite loop. Now it's done. All right, so let's think about the grid. Now the grid, it's got, let's see, 3, 4, 5, 6, it has 7 columns. And it has 6 rows. So we're going to need to print 7 columns and 6 rows. 7 columns and 6 rows. 7 columns and 6 rows. So the columns go from 0 to 6. Those are the columns. And the rows go from 0 to 5. What did I say? 6, right? Wait a minute. These are 7 columns, sorry. 7 columns. So that's going to be 0 to 6. And 6 rows, that'll be 0 to 5. What do we want to do first? Do we want to do the columns first, or do we want to do the rows first? Which one do we do first? Let me see. So I'll have to print the, oh, I see, because we're in the console window. So we have to print this first row first. Then we're going to print this next row like that. Now, is this going to be, is this row 0? Or is this row 0? You know, the bottom, we'll make the bottom row 0. That's, I got agreement there. And this will be column 0. This is column 6, 0 to 6 at 7 columns. All right, so we're going to fix the row, and then we print the 7 columns. So that means the rows are in the outer loop, or this row index is managed by the outer loop. So once we fix a row, and actually we have to print the top. So we're going to print row 6, which is 5. All the way down to row 0. So the first thing we want to do is print the contents of row 5. Right, this is row 5. Row 4, 3, 2, 1, 0. This is row 0. That's the last thing we print because the console things are going to scroll up, right? So first we print row 5, and we end up with print row 0, and that's how we do it. And this is wrong. This should be plus R. Then we print the columns. The columns are 0 to 6. Just to have the same sort of format, we could do it like that because we're doing greater than or equal to here. We could do less than or equal to there. We can do that just to be kind of consistent. Yeah.
Would you have to subtract R?
Yeah, because it starts 6.
Oh, you're right. Thank you. Yeah, we have to subtract. Excellent. Starting at 5, and we got to subtract. And so each of these, so there we have a slot here, like this slot right there. And we'll go this one. Let's look at that slot right there. That slot where the arrow is. That's going to be column 1. Right, because we count from 0. Column 1. That's going to be row 1. Right, so inside this loop, at this point, what am I doing? What we want to do is we'll have a record of what's in that cell. Row R, column C, what's in that cell. So we're going to have a two-dimensional array. So we need a two-dimensional array to store the state of the grid. So we'll call it, and I'm going to do it like this. I'm going to make it a char array. And it's going to have 6 rows and 7 columns, like that. So we're going to output the grid, row, column. So we're going to, once we fix the row R, we're going to run through the columns, 0 through 6. After we run through all the columns, we'll need to go to the next line. I'll do that later. You see how that works? So a grid cell will either have an X in it, say for the player, an O in it for the computer, or we could use P and C, whatever. I'll use X and O. So we'll have X for a player, O for the computer, or we can use a period or a blank. I think I'm going to use a period there. Now this grid is uninitialized. It's a grid of characters. C-H-A-R, characters. It's character data. It's 1 byte. Initialize the grid. The first thing I'm going to do here inside main is I'm going to initialize the grid. This grid is uninitialized. It has random information in it. Let's see what it does, actually. Let's see what that does. Without initializing the grid, what are we going to get? See this, we've declared the size of this, but it's not, we didn't say what the contents are. So we're going to get random data. So we're just getting blanks there. So let's implement initialize grid. And it'll be a loop just like this. To run through the rows and the columns. And for each pair RC, we'll set the grid cell to dot. It's an open cell. Now notice I'm not using quotes here. I didn't use quote because char, the grid is holding, it's not holding strings, it's holding characters. So character data is specified using apostrophes like this. Initialize grid. What did I do?
Oh, the bottom one.
I spelled this wrong?
Yeah.
Initialize, oh, there it is. There it is. And now we're not playing anything. Also, the dots are a bit close together. Let's get a little space in there. Let's make some space. So when we print this thing, first we'll print a space, then we'll print the symbol in the grid cell, and then we'll print another, no, that's it, just a space like that. Maybe two spaces. Looked like it needed some extra space there. Yeah, that looks a little better, doesn't it? So we might want to put a new line in there. After we print the grid, let's just put a new line in right there and make it easier to look at. There we go. Column 4, column 5, like that. All right. You see how we're getting there? Step by step. We haven't done that much yet. We've got this user input, computer, this loop in which the user does input and the grid, state of the grid changes and we print the grid. We got that done. Now let's, I'm just thinking, what's a good choice to go next? What's to do next here? Well, let's let the user's symbol appear in the grid now based on the selected column. So when we enter a column number here, we need to let's use X for the user. We'll need to put an X somewhere. So, it'll be, let's just do it like this. We'll do, I'm showing you right now, I'm going to show you one way to sort of get a solution here. So I'm not looking that far forward here. So the user enters in a column number. So basically, it's going to be row 0, given column is going to get an X. See, This is not a string, it's a character, so I use apostrophes. This is not a complete solution. This is just putting things in the bottom row. All right.
What's happening here is not normal.
Column
It's
1.
extraordinary.
What is
You're not
going
sure
on
what's
there?
on the other side, but momentum pushes you forward. And it's why we're with
What's
you.
that?
80,000 people now, on the ground, in the air, engines on. Because there is no stop in us. Or you.
Not working.
Only go.
Oh, it's gone. Anyway, they got their advertisement in there. All right. So I picked one like it's now here the user's entering in 0 through 6. I mean, we can make it easy by subtracting 1, so make it user friendly. Well, let's not do that now. We'll do that later. That's icing on the cake. Let's bake the cake first. So we have another. That's column 1. This is column 2. This is column 0, right? Column 6. Well, what if I do column 1 again? Right, it doesn't show anything because I already have an X there. So what we want now is we want that X to stack. So when I choose column 1 again, I want to see 2 X's, one on top of another. The new X needs to slide down and occupy that next higher space. That's one way to go. I think that's the way I want to do it. So how are we going to do that? How are we going to, instead of fixing, row 0 as the place to get this symbol, we have to find, basically we have to find this, we'll start at the top in row 5. Oh no, we'll start at the bottom at row 0. If there isn't an X or an O there, if there's a dot there, I'll put the X there. If there's not a dot there, I'll add 1 to the index and I'll consider the next higher row. If there's a dot there, I'll put my X there. If there's no dot there, I'll go to the next higher row. So I've got a loop. So it'll be, and we're iterating through these rows. We're going to start in the bottom. And we're going to stop at 5, right? And if the grid of our column, if it's a dot, that means it hasn't been taken. That means that's a good spot for the X. And I'll put the X there. Now what happens if we do put an X there, then we're going to break from this loop. We don't need to we found, not grid 0, but that's grid row R. See, we're iterating. We want to find, we know the column. The user said, I want to go into column such and such. So we have that number stored in the column variable. Now what we want to do is find the row with that column and put the X there. So we start at the bottom 0. We work our way up to 5. As soon as we find a dot, we'll put the X there and then we break the loop. Got it? Let's see if it works. All right, column 1. Column 2. Look good. Column 1 again. Look, it's stacking. See that? Isn't that nice? You see, it's coming together, right? This is where it gets satisfying. This is where you tap into some emotional energy here and say, look at what I got working. And then let's do the next thing. And then I tell you, it's like playing a video game. It can be addicting and then rewarding, as well as frustrating, just like a video game. So now, one problem we have is, and I'm not sure we want to handle that right now, is we can go past this column to sort of an invalid column. So I can't keep putting it in there, but I'm actually writing into memory in a place that I'm not supposed to be writing an X. So I don't know if I want to put that control in there or not right now. I think I'm going to wait on that. Let's handle that later. Now this whole chunk of code here, this is where the user makes a choice. So I want to put that inside of a function. And I'll do something like, oh, I know what to do. We'll call it user choice. There's the column, right? I'm just going to use C there just to make it shorter. And then we just call user choice. User choice. Did I do that right? No, that's a C. User choice, integer, and then pass in the column. And I got rid of the word column. I'm just going to use C. It's clear what that means. Let's not go too far without testing. So we're going to test this thing. That seems to work. All right. And let's do the computer choice now. You know, after the user choice. Is that a good word? Is that a good phrase, or is that a good function name? User choice. Is there a better name for that? Computer choice.
Move.
User turn.
Computer move.
Computer move. Yeah, I like move. User move. Yeah, let's use move. I like that better. And this would be user move. This is called refactoring. When you say, well, you know, the name I just chose, I don't like it. It's not, it just doesn't, it doesn't help me understand the problem. So you change it. So you do these, change your variable names, function names, as you go along to make the code easier to read and develop. All right, what about the computer move? Well, we'll need a value for that. So we could use the random function, right? And we do mod, how many columns? 7 columns, right? So 0 through 6. I do mod 7. That gives me a remainder that goes from 0 to 6. Oh, and the computer, we need to implement computer move. First, I got to fix this. computer move. And instead of X, we're going to use an O there. Now look, we look at these two functions are identical, except for that one spot right there. So that's called code duplication, and it's good to remove code duplication. So I'll show you in a minute how to remove the duplication there and to remove the common logic. All right, I'll go in 2. I'll go in 0. Look at that. It's already looking like a game, isn't it? We're making moves. The computer's making a move. Oh, I should win right there, right? It should say player wins. So 4 in a row. Look at how far we've gotten already. But you can see it's just in little pieces, little baby steps as we go along. And don't resist the lazy feeling of not changing things around. Like, well, I know I got code duplication here, and I'll live with that. Or, yeah, that name isn't very good, you know. I'll change it. I won't worry about that. I know what it means now. But resist to that. You should always be cleaning, always reorganizing. It's called refactoring. Your code should be kind of like, you should be constantly cleaning and organizing your code to make it more readable. Let's think about how to remove the redundancy. I'm going to copy this block of code here, and I'll just call it move. So we're going to move into column C, and we want to put a symbol in column C. See? And the symbol is a char. There it is right there. That's the common logic right there. So now we don't need this loop anymore. The user move looks like this. We call move C X. You know what? I just don't like that order. I like to put the symbol first, and then the column. So I'm going to change that up here. It just reads better to me. I don't know if it reads better to you. This is just an example of a refactoring. To me, it just reads better like that. Same in the computer move. So that should be an O. Look at that. Those functions now become one-liners, and our common logic is grouped in this move function. Let's check it. Make sure that it's running. Clear. Looks good. All right. What do we do next? Well, there's a problem because the computer can move. The computer might choose a random, an invalid column, right? Maybe the column is already full of symbols, and the computer doesn't know that. So we need, when we compute a column for the computer to play, we need to know that there's an available cell that the O can be placed into. How are we going to do that? Let's think about that. Huh? Say it again.
Check if the fifth row of the given column
Yeah.
has a period. or not.
Yeah. That's a good idea. Let's do that. That's a great suggestion. And I'll just do it like this. It'll be a bool, and I'll say, can move into column C. And we just return grid of 5C equals dot. And so now, here's one way to do it. It's a sloppy way to do it. I'm going to make an infinite loop. Sometimes I just start with an infinite loop and then I change it. I add a condition just as a way to progress through the solution. So when we compute the random column, I say if we can move into that column, then let's move there. Else we'd continue with the loop. Also, after we move into that column, we're done with the loop, so we want to break. So we just keep trying until we get a good column. Let's see if that works.
We didn't close the if statement.
What's that?
We didn't close the if statement.
I need a what?
Close the if statement.
Oh, yeah, thank you. That's great. You guys are paying attention. Really, very good. All right, 1, 1, 1, 1, 1, 1. I don't know how to test it. I think the computer, I think it's not picking any bad spots, right? Look at that. It fills it in. No, next one. So now it should show tie. Well, actually, the computer wins, right? Or I win, I don't know. So, well, let's forget about checking for a win. Let's check for a tie. A tie means player didn't win, and the computer didn't win. But there is no available column, right? So let's check for a tie. And is tie? Is there a tie? How are we going to check for a tie? Well, I know how I would do it. What we got to do, well, just like in row 5. If there's a dot in any column in row 5, then it's not a tie. If there's a symbol other than dot in row 5, in every column of row 5, then it's a tie. So we want to repeat, let's see, how many columns are there? There's 7 columns, right? So for C equals 0, C less than 7, plus C. And if, watch this, if we can move to C, then it's not a tie, so I'll return false. And if I finish the loop and I don't, and can move never returns true, then I know that it's a tie. I could, instead of saying can move C here, I could just use that expression right there, right? But what's easier to read? Can move, right? It's the words are there. It runs a little slower because you have to call a function. But so what? I mean, no one's ever going to notice the difference. So it's more readable. When I call this function, it's the readability goes up rather than just inserting this in there. And for this, and the same reason holds for why we're using can move there as well. I could have put that expression inside this if statement. Then I wouldn't need a function, would I? It's nice to reduce the number of functions, but then it becomes less readable. It's much more readable when I say can move. Otherwise, you have to look at this expression and say, oh, that means I can move there. And then maybe you'd have to put a comment there. If there's a dot, then you can move there. Forget that stuff. Just have the function, call the function, make the name of the function meaningful so it's easy to read, understand as your code develops. Now we're going to check for the tie here. So after the user moves, oh, and look, this is where the computer moves. Like, this is not readable for me. I want to go user moves, then I want to do the computer moves. Did I have that already? I did, didn't I? I didn't fill it in. That's computer move. Look at that. Oh, I did it here, right? Well, I have it on the inside here. I see. Okay, wait a minute. So what I want to do is I want to reorganize this. And I call the function computer move. I want to put the AI in there. So inside the function computer move, I want to choose the random column. So I'm going to pull this out. Take all that logic out like that. Put it in here. And what was that last thing I just, wait a minute. This should be just move. And this should be O. And this is column. And I just want to get rid of it. And we know that C means column, so I'm going to just shorten that up a little. And that's an int. So now we have that kind of like the AI inside this computer move function. And it calls move inside of there. User move still now just calls. Oh, we could do the same thing. Let's make this parallel. When the computer move is an internal, artificial intelligence algorithm. But the user move is we need to interact with the keyboard and get the user input, and we need to prompt the user as well. So what we want to do there is move this into user move. So this will make it, this will give a sort of a parallel design. So we have the computer move does what it needs to get the column, and then it calls move with that column. The same, similarly, user move does what it needs to do to get the column, which is interact with the keyboard, and then call move. So it'll be move, and oh, we got that there. We already need that. So we prompt the user to enter a column, and then we move it. We could do the same thing with this can move. So we could catch the user if the user is picking a bad column. We'll stay in a loop here. Let's do it like this. Watch how this works. I hope I'm not losing people here. So we're going to loop. We're going to keep asking the user to make a move until the user enters in a valid move. So when we get the C here, we test. If we can move, then we'll move it and we'll break. Otherwise, we stay in the loop and keep asking the user to pick a valid column. So that's user move. Oh, by the way, user move does not take an argument, and computer move no longer takes an argument. So we've refactored those functions. We've changed their form. Now they sort of stand alone. They gather their own column position, and then they call move with that column position. A nice parallel design. We're going to do user move. And computer move does not take a column. Computer move gets its own column, user move gets its own column. We just do user move first, then we check for a tie. If it's a tie, then we're going to see out tie. And then what? And then break. Actually, we can return. So we can return from, well, we'll do break. Let's do break. We'll break the loop. And then we do the computer move. And we have to do the same thing. We check for a tie. But if the user always starts first, I think that there's never a tie after the user moves. It's always after the computer moves. So this block of code is probably unnecessary. But if we change, I'm going to leave it in there because if we change this later and we maybe have the user go second sometimes, then we'll need to do this check. And you see there's a duplication of code here. This printing tie is a duplicate, but it's so small I'm going to leave it in there for now. Can move. Can move is undefined. See, computer move calls can move. A can move is defined after the place where we use it. So we're using can move here, but we define can move down there. Oh, we're running out of time. Now watch, so let's just finish this and then we'll call it quits. So this is move. Actually, it makes sense. I was going to put it here, right? But no, can move should precede move. It's more readable, isn't it? Can move should go before move. All right. All right, so we're going to go in column 1. Now watch this. I'm going to pick column 1 again. And so we should sit in the loop where we want. We're just going to enter a column number for your move over and over again. See that?
Mm-hmm.
So it's refusing it. So I'm going to go into column 2. There we go. Now we're back into track again here. And, oops. not doing this well, am I? 0, I'll go into 0. 1, 2, now I'll take 3. 3, ready? 5, and what should happen? It should say tie. And there, oh, but it doesn't print the board. We want it to print the board, so let's fix this. Hang in there, almost done. So if it's a tie, we want to print the grid. After the user move, we want to print the grid, right? And we want to, after the computer moves, we want to print the grid. And we want to print the grid initially, after we initialize the grid. That's how we do it. I'll do it real fast here. So 0, 1, 2. What am I doing? I forgot to do break, right? So print grid, I'm just going to put it inside print grid. No, I shouldn't put it in print grid. It's not the right place to put it. We print the grid. No, maybe it's all right. I'll put it inside print grid. Change my mind. So inside print grid, I will put a new line right there. Okay, there we go. So 0, 0, 0, 0. 1, 2. All right, ready? So I'm going to play, what happens when I enter 5? Should display the grid completely filled in and say tie. And it does. So now we have to add code that checks for a win, because one of us would have won before we reach this point. And then we're essentially done the main game. Then there's some icing we can add to the cake. We can check for illegal user input and that sort of thing. But look how close we were, almost finished this thing. So next time we'll continue. All right, that's it.
No, no, it's in the